Welcome to GATE 2021 Model Questions on Control Systems. Today's our topic is time response analysis. Let us see the question number 1. We are given an open loop transfer function of a unity feedback system as g of s is equals to k by s plus a into s plus b. When the closed loop system is subjected to a unit step input, the output has an overshoot of 16.3%. but ultimately attains the final value 1. The response to a unit ramp input has a steady state error of 0.0625 and asking to find the values of K, A and B to meet the data. Okay, let's go for the solution. What is the open loop transfer function they are given as? G of s is equals to K by s plus a into s plus b. And whenever they apply the unit step input, the output at steady state or the final value they are getting as 1. That means the steady state error for that unit step input is indirectly 0. That is output equals to applied unit step input. Whenever they apply input as unit ramp input, that is T, what is the steady state error? They want to get it as 0.0625. To meet this data, you have to select the values of K, A and B. Obviously, if you want to get the steady state error for unit step input as 0, compulsory the system should be type 1 system. Type 1 system is one open loop pole should lie at origin. To lie open loop pole at origin, which one you have to select? A or B, as A should be equal to 0 or B should be equal to 0. Whenever A or B is 0, then only that will become type 1 system. If you see the options, what they are given is A equal to 0 is there. There is no option with B equal to 0 actually. Therefore, indirectly they are selecting in the given options as A as 0 instead of B equal to 0. You can take B also 0, then you'll get A answer. If you take A 0, you'll get the B answer. Okay. For A or B, you have to take 0. In all the options A, they are taken as 0. This, whenever we take A as 0, the open loop transfer function will become K by S into S plus B, which is a standard second order system model. And it is a type 1 system whose steady state error for unit step input will be equal to 0. Now your question is, still one more data is there. To meet the peak overshoot for that unit step input, they want 16.3%. Peak overshoot they are given means indirectly they are given for us damping ratio. How to calculate the damping ratio for the given overshoot is zeta is equals to minus log base C peak overshoot by 100 divided by root over pi square plus log base C peak overshoot by 100 whole square. You substitute here peak overshoot equal to 16.3 and find the damping ratio, which you'll get it as 0.5. And one more data what they are given is, and they want steady state error for unit ramp input to be 0.0625. With this data, we can find the values of K and B. What is the characteristic equation of the system is 1 plus G of s is equals to 0, 1 plus K by S into S plus B equal to 0, or S square plus BS plus K equal to 0. Compare this characteristic equation with the standard second order system characteristic equation. That is S square plus 2 zeta omega ns plus omega n square equal to 0. If you compare it, what is omega n is root K. Okay. What is 2 zeta omega n is B. From here, what is the damping ratio is B by 2 root K, which they given damping ratio as 0.5. Let it be equation number 1. Next, what is the steady state error for unit ramp input is 1 by kV, where kV is limit s tends to 0 s into g of s. If we substitute s equal to 0 in s into g of s, what we'll be getting as k by b. Hence, the steady state error for unit ramp input will be 1 by kV, which is b by k, which they want it as 0.0625. This is your second equation. Solving this 1 and 2 equation, we can find the values of b as well as k. Okay. What is the value of b from the second equation is 0.0625. Substitute the second equation in the first equation. What we'll get it is 0.0625 divided by into k, 2 root k is equals to 1 by 2 or 0.5. From here, what is root k is 1 by 0.0625, which will get it as 16. From here, k is 16 square, which is 256. Substitute this k equal to 256 in the equation 2, we'll get the value of b as, what is the b is nothing but root k itself, that is nothing but 16. Either from first equation, b will be equal to root k, or from the second equation, b equal to 0.0625 into k. Anyone you do it, you'll get k and b value. So which is the correct option? And a is already selected as 0. Which is the correct option is C. Thank you.